right, so for this problem, we have 5-15. So this is our circuit. We get a 40 volt power supply, a 10 ohm, 18 ohm, a 4 ohm, a 3 ohm, and a 6 ohm. And then we have three capacitors, a 20, 60, and a 10 mu farad. So it's going to say determine the voltages V1 to V3 in the circuit. So I think it gives us, this is V1, V2, V3. And let's make that pink just so we can not get them into the circuit. V1, V2, and V3. And they also gave us the directions of those voltages, which is important so we get a direction correct. Positive, negative, positive, negative, positive, negative. All right, so what it's asking for is, what are the voltage drops in here? And so this is a DC circuit. So again, DC, what happens to capacitors? DC circuit capacitors go bye-bye, so we can get rid of those. So I'm just going to even cross them out here. Boom, boom, and boom. So our new circuit, when we draw it, is going to look like this. We're going to draw our new circuit to look like... so that's where to start. 3... we're going to draw this as our plus minus 40. Let's start with ones we already have. Our resistor there. Resistors don't go anywhere. So we already have that. And then we have another resistor. It doesn't go anywhere. So what happens to capacitors at this? They get popped out of the circuit because essentially they saturate and then no current flows through. And that makes it easy for us to calculate the rest of the circuit that we need to calculate. So this is going to be a capacitor drop there. And this is another drop there. Hey! Excuse me. And then we have another resistor up here. All right, so let's just simplify this one more time. Let's pull these capacitor ones out. So this is going to go over to here, and this is going to be positive, minus. Okay, and then this is going to be a resistor over. This is going to be a resistor down, wall, resistor down, again to this. And then this is going to be a resistor over to that. So that's our circuit. Essentially, when we pull all of our caps out, and this is going to be 10, 18, 4, 3, 6. Okay. So if you remember, if I did this on the board, the first time I did this around, I had these connected. So if we did this in class, because we stopped on this one in class, I had connected these accidentally because that's the wrong thing to do because this is an open circuit and not a connection. So if you had something wrong there, I tried to correct it in class, but I think a couple of you were confused. So this is, again, this is the correct circuit. Of course, there's nothing going through. That makes no sense whatsoever. So let's begin. So how do we do this? Well, we're going to look at, we have two nodes here. This is VA and VB. You can do this multiple ways. You could do Kirchhoff's voltage law and get 3 different loops and then solve for, actually you get 2 loops, wouldn't you? 1 loop and then 2 loops. So KVL is a pretty good way to do this. KCL, you also get 2 points, so you get 1 and 2. So, I mean, either way works. I like KCL a little more. If you want to do your loops, you got 1 loop and 2 loops. There's nothing down here. This is open. So, for our KCL at VA, at node A, we're going to get, that's this one up here, we're going to get our source minus our VA minus our source, because again, we're going to draw these coming out, and coming out, and there's nothing there. This one's coming out, coming out, coming out. So I1 plus I2 plus I3 equals 0. All those are coming out. We've got VA minus 40 over 10 plus VA minus VB, because it's the difference between the two. And we have a resistor in there, don't we? Yeah, we have 18. And then we have one more coming up, and that's going to be plus VA minus VB, because this is, again, VA all the way around to VB. VA, VB. Let's label it down here. VA, VB. So the difference between these two is all the way through there around. So VA minus VB over 9, because it's this one plus this, through both of these. It's going to equal to 0. That's our first equation. And then we're going to do KCL at VB. And then KCL at VB is going to be, again, we have this one, so this is going to be easy going right through this resistor, and this is what, 4. So VB, which is the point, minus over 4, plus VB minus VA over that resistor, which is 18. VB minus VA over 18. And then plus, we've got this one again. So this is going to be through both of these. So this is VA minus VB over 3 plus 6. So that's VA minus VB over 9 equals 0. Booyah! 2 equations, 2 unknowns. Let's solve. If we solve, I'm just going to shorten this. VA equals 20. VB equals 8. Okay? That's nice. So then if we have both of those values solved, we're going to have to be able to go through again to be able to find now, because, all right, let's step back. This has found our total, essentially we have total resistance. If we want our current coming out, we can get it pretty easily there. These two are in series, they're in parallel with this one, and this is in series with this whole chunk and that. So anyway, that's one way that we could do it. Another way to be able to do this is to solve the, well, we need to find the voltage drops over each of these. So we need to be able to find those, essentially those drops now when we plug them back in. Because again, these aren't, they're gone at DC, but there is still a voltage drop over them. So we need to find the voltage drop from here to here because that's a voltage divider in between the two pieces. So in order to solve that, we're going to do KVL at each of these individual drops. So again, this one is, where did I label these? This is V1. So let's go back to this one. This is one loop. This is one loop. That's one loop. So this V1, we're just going to do that. KVL, and let's call it, no, we already used that. Let's call it brown loop. That sounds good to me. Look at, ew, that does not look like brown, but whatever, we'll solve it. We'll work with it. So this is KVL brown. KVL, then we'll call that loop 1. 1 loop. Okay. And so for this one, we are going to have our this, which is V1, which is a voltage, because again, this is going to become a battery if we take this away. So we have our voltage drop over that, which is V1, actually minus V1, because we're going to go in this direction, and this is negative to positive, so therefore minus V1. And then we're going to get minus, what do we come around here? Well, we got our VB, so minus VB. And then we're going to have plus our difference between VB and VA. And then we're going to have, again, what are our values? We're going to have 1/3 of that equals 0. Good, that looks good. So we're going to just hold on to that. We have VB, we can substitute VB in as 8. 8 minus 20, 1, 8, 2, VB, 1/3 of that, minus V1 equals 12. Well, is that right? Let's check. So we have VB negative positive, so minus 12. Okay. And then we're going to do KVL loop 2. KVL at loop 2, and loop 2 is going to be going through these up here. We got our loop 2. So our loop 2 we're going to do right through this entire piece here. Lump. And so our KVL at loop 2, we're going to get, this is V3, and this is the negative direction, so minus V3, minus, the next one is V2, minus V2, plus we've got then our VA minus VB. If we're coming down across here, VA, VB. So we've got VA minus VB. And then we've got the resistance between those, which is going to be 18.3, so that's 2/3, right? 2/3. That's going to equal 0. And then if we solve that out, we're going to get V3 plus V2 equals 8 volts. Okay, that's just algebra. We plug in those values again. VA 20, VB 8, 2/3. So that's going to equal 8. And then the next part that we're going to do is to look at another equation because we need one more equation. I'm going to block this part off here. So for two capacitors in series, again, our voltage across them is going to be the voltage times the capacitance because essentially you got the two values there. So V1C1 equals V2C2. And that's going to solve, again, our two voltages. So our V1 is going to be, well, actually we should call that, actually this is our V2, and this is our V3, and this is our C2, and this is our C3. That's better. So our V2 is going to be the voltage drop across 2, which we don't know. So our capacitance 2 is going to be, what is that, 20? So 20 V2 equals 60 V3. And we have our second equation here. So solve both of these. 8 equals that. We're going to get V2 equals to 6 volts and V3 equals to 2 volts. All right. I hope you could see that. So just to walk through again, equation 1, equation 2, solve, solve, and that gives our voltage drops over them. Whew. All right, next one. Moving on.